Welcome, Brucho.
Hello.
Hello.
Brujo, actually, but yeah.
Brujo!
Hi.
Sorry.
No problem.
Yep, sorry. Yes, welcome, Brucho. And your presentation, Erlang Oddities.
That's it.
So, welcome, and the stage is yours.
All right, thank you very much. So this is a presentation called Erlang Oddities. It's a little bit slightly old. It has a couple of years since I first gave this talk. It was in a conference in Buenos Aires, and it was in Spanish. So we will see how it goes in English now. So I'm Brujo Benavides. I am currently living in Spain, but I come from Buenos Aires, Argentina. I've been working with Erlang for more than a decade. I've been working as a developer, as a trainer. I organized conferences and events and whatnot. But most importantly for this talk, around the year 2016, I created my blog. It's called Erlang Battleground, and at this time it has more than 50 or 60 articles there, and most of them are about Erlang oddities, particular details in Erlang that are funny or interesting or amusing. So I encourage you all to read that. Over here, I collected a couple of them, but of course, not all of them. And this talk is based on this other talk. It's a talk called What? And it's delivered by Gary Bernhardt. And it's hosted on Destroy All Software /talks/what. It's a very, very funny one. One of my favorite talks about software from all of them. And if you haven't seen it, I encourage you to see it as well, to watch it, because it's just 5 minutes long and you will get a proper laugh about it. And our profession is not to be taken too seriously, and Gary knows that. So, but I am not Gary. I am a regular guy. Gary is a programmer, but he's also a stand-up comedian. So in this talk, I will try to make it as funny as possible, but most likely I won't get to Gary's levels of hilariousness. To compensate for that, I will include many, many puns, because I'm a dad, so I will do dad jokes all the time. And in this time, you will have to bear with me. Also, this talk was first conceived to be delivered live to people, to an audience. And I don't have a laugh track here, so I hope everybody's laughing at home. And if you're not, I will imagine that you're laughing at home. To kick off this thing, let me present the issue at hand. It's a story about an interview where one exercise that's part of the technical interview, you know, that process that we all love in our profession, is to write the code for a FizzBuzz algorithm. And these are the rules. We need to write a script that's given a parameter. It's called n, and it prints all integer numbers that are below it, one after the other. And for each one, if the number is divisible by 3, it prints fizz. If it's divisible by 5, it prints buzz. But if the number is divisible by both, it has to print FizzBuzz. It has to print an error if the provided parameter is not a number. And for whatever reason, it has to work with floating point numbers too. Particular part of this is that we usually oversee is that in this case, it has to be a script. It's not expected to be just a function. It actually has to be runnable on command line. I will get to that by the end of the presentation. So, myself, Erlang developer, faced with this task, I will try to do it as wrongfully as I can possibly do it. So in the worst possible way, I will try to solve this exercise. So first, if you've ever seen an Erlang module, it starts with the module declaration, but even the most experienced Erlang developers have never seen a module like this one. Because usually, in every documentation, the attribute module contains an argument, FizzBuzz, between parentheses. But for like trying dumb stuff on my computer, I discovered that those parentheses are actually optional. So this thing, this whole line with the colon at the end, is actually a complete Erlang module. If you go to a console, you can compile it. And it compiles. Perfect. It does nothing, it has no functions, but it exists. So let's start adding some actual stuff to it. So the first thing I will do is to add a function called up2, which takes a number and then calls an auxiliary function where I will write it in a recursive manner so that it goes through the list from 1 to number and it prints all the numbers. Printing in Erlang is IO format, and that string interpolation with the P replaces the P by the parameter provided. And so this function basically traverses, goes through the numbers one after the other until we reach a point where we get a number that's larger than the top number. In this case, it prints tilde n, and that prints a new line, so it just terminates. Let's see if my code works. On a console, we can try to compile the module again, and it compiles. And if we run the function that is exported up to 1, like a number, it actually works. But of course, the exercise required many more things. This is just the first step. So far, so good. So the next step will be, because I choose so to implement error handling, error detection. So to deal with what happens when a parameter is not a number. As I showed you before, I have this auxiliary function where I said I have two clauses. One is for when top is larger or equal than I, and the other one is when top is smaller, shorter than I. So I can add the validation of numericness to them, like this. So basically, the first clause will be evaluated when the provided parameter is a number and it is larger or equal than the iterator. And the second one will be evaluated when the provided parameter is a number, but it's shorter than the iterator. And then I have to add the error display, something that happens when it is not a number. So in any other case, I will print an error message like this and return error. And that code looks perfectly reasonable. So we go to the console, we compile the module, it compiles, nice code, perfect. So we try with something that's not a number. That thing is an atom. In Erlang, you can write words, and those are considered atoms, as long as you don't use special characters or uppercase or whatever. So that thing should print the error and return error. And that's what it does. And now the interesting part starts. Usually, I would ask the audience, what do they think this would do? So remember that we have the guards saying that if it is a number and it's larger than or smaller than, whatever, and it runs the same algorithm as before, I didn't change the algorithm, the previous algorithm. So it should print 1 to 10. But instead, it tells me that 10 is not a number. And why, right? How did that happen? Well, turns out that and has a smaller precedence than the larger and equal sign. And that means that the code actually evaluates the first clause when is number top, and top, all that thing, is larger or equal than 1, which can never be because it's either true or false and it's smaller than number. So even when it's readable, it's wrong. And how do you fix that? Well, you have to use another version of and, this one, and also. And also is a short circuit operator. And so this time it evaluates everything to the left of it first. And if that is true, then it evaluates whatever is on the right. If not, it's false. So it has by design, it has a larger precedence, it works as expected. So if you ever end up writing code in Erlang and you put and, be careful, strange things may happen there. So we compile just to verify that I'm not lying to you. And we try with something that's not a number. And of course, it fails because it doesn't match any guard. But if we try with something up to 10, it works perfectly fine. Now, let's start, let's move the validation to the proper place because it was there just to show you what bad things can happen. So I put the validation first, not in every step in the recursive function. I put it on the outside. So up to number, if it's a number, it goes to the internal function. If it's not a number, it prints the error there. Just for the sake of it, let's try again and compile, and let's see if I didn't make any mistakes. It does compile, prints an error when it's an error, and of course it counts to 10 as expected. That's fine. And now we will start adding fees and bus and all those things. So what's the deal here? I could implement the fees and bus part in multiple ways, but as I told you already, I will do it in the most incorrect possible way. So Erlang is a functional programming language. I will do it imperatively, just because. And I will use the worst possible keyword in Erlang, which is if. But even in that case, the code looks reasonable. It looks like this. If the number I'm going to print is divisible by 3, so the remainder of 3 is 0, it prints fees. If the remainder is of 5 is 0, it prints bus. I don't need a clause for when the remainder is 0 for 3 and 5, because since they are printed in order, it will actually print fees bus as expected. But I need a clause for when it's neither. So if it's not a multiple of 3 nor 5, it will print the number as it was printing before. After printing that, it prints a space and moves to the next step. Easy peasy. Let's see how that works. We compile the thing, fine. We run up to 10. And if you expect here to start seeing fees and buses, I'm sorry to disappoint you, but there are no true branches when evaluating an if expression. What just happened is a consequence of Erlang Erlang functions being composed of multiple expressions. So if everything inside an if, from an if to an end, has to be an expression. And so if it doesn't match any of the classes, you still need to match something to let that expression evaluate to a proper value. And so you have to add an else. Basically, there are no else-less ifs in Erlang. You have to add an else everywhere. And an else looks like this. Semicolon true arrow. And why? Well, nobody bothered to add an else keyword. And so basically you have to complete all the clauses. And a clause that matches everything that is always true is, of course, true. So that's the way to do else in Erlang. You can see how why nobody likes ifs in general, but nobody likes else's in Erlang, because this thing is very, very ugly, and everybody wants to write code without it. There are good ways of doing that thing, for instance, using pattern matching on function clauses, case expressions, some other things, but also many wrong ways to skip the else-less if. And I will show you 3 of them today. But just to be consistent, I will compile this version of the code and run it up to 10. As you can see, it works. As you can see also, there is no fees bus there. It's fees bus, but not fees bus, because I didn't reach a multiple of 3 and 5, like 15. So maybe if I run this, we will run into a different error that I can show you, but not this time, not today. Now let's move on to the else-less ifs. So you see, the goal here is that you see how the camera had to zoom on the slide. There is too much text. We want to remove the second column. That's our goal. So everywhere that there is an if with 3 rows, we want 1 row there. And the first way to do it, and I tell you, these are wrong ways not to do it. You don't have to do this at your code. But on the other hand, these are real ways. I found examples of all of them during my work in different companies that I will not mention in Erlang. The first one is this very, very creative one with our old friend and also. We moved from this to this. What did we do? We turned an if with an else with an else that we didn't want into something that is a Boolean expression, but it's short-circuiting. So if the first part is false, then the whole expression is false, and the right side of and also is not evaluated. And if the left part is true, the right side of and also is evaluated. And since Erlang is a dynamic type language, it doesn't matter if it doesn't return a Boolean. Erlang just evaluates that thing and returns whatever goes with it. And since we are dropping the value of this expression, we are not using it for anything, it's fine. And so this is basically an expression that either returns true or prints, either returns false or prints this, which is exactly what we wanted. And we can check it out. We ran it up to 25 and effectively works. So 1 out, 2 to go. We got the second one, and now this one will be super, super tricky. If you're not used to Erlang, and particularly if you're not used to list comprehensions, this will be complex to understand, but let's see what we can do. So basically, we will turn this thing into this one-liner. This is a list comprehension. If you're familiar with, say, Elixir or Python or whatever, it's for this enumerable thing, do this thing, or filter this way, do this thing with every item. In Erlang, that thing is written this way. To the left of the double pipe is the expression to be evaluated for each item. And to the right of the double pipe, there are the filters, the generators, and the filters. But as you can see there, you can write the list comprehension without generators. So basically, you don't take your input from anywhere, you put a filter or many filters on the right, and you put an expression on the left. And because list comprehensions are a syntax sugar in Erlang, this is not rejected by the compiler nor the runtime. This is turned into some nested case statement with anonymous functions and something like that, and basically does the following thing. If the filters are all true, in this case we have just one, so if the remainder of 5 for I is 0, then this will generate a list with a single element, and that element will be computed using the expression on the left side of the double pipe. In this case, whatever the result of EO format bus is. But if at least one filter is false, then this expression will not be evaluated. The expression on the left side of the double pipe will not be evaluated, and this whole expression will end up being an empty list. So, as you can see, this actually serves our purpose, because when the item is not divisible by 5, the empty list has no elements, EO format is never evaluated, we don't see buses there where they should not be. But at this point, let me digress a little bit on these things that I would like to call list incomprehensions. And let me show you something more that I couldn't include in the example. So, as I told you, this is a list comprehension with just a filter, no generator. If the filter is false, the result, the expression evaluates to an empty list. If the filter is true, the expression evaluates to a single element, a list with a single element, which is the expression on the left. And now, think about it. If the expression is neither true nor false, should the compiler just fail, like tell you that you don't have not a generator, not even a filter there? I would expect so, but that doesn't happen. Or maybe the runtime. Okay, if the compiler can catch it, maybe the runtime can. And so if you run this thing, it will tell you that you have a wrong generator there or a wrong filter, or this thing doesn't make any sense. I cannot provide a result for it. But actually, if you run this thing, this is what happens. So basically, only if the filter is true, you get a list with a single element, anything else, empty list. And I think I could live with that. I thought I could live with that until I found this thing. This is the famous identity function. It returns anything that you gave. You give a banana, it gives you a banana. Easy. It's a function, anonymous function, that's fine. And so identity of false is false. And so this list comprehension is, of course, an empty list. Perfect. And identity of true is true. So this list comprehension is, of course, a list with a single element. Fine. And this expression is something. So this is, of course, an empty. Okay. What? Why? Why are you complaining about bad filter now? And why, if there is an exception called bad filter, it's not returned in line 24? I don't know. I once tried to check the code behind this thing in the Erlang OTP implementation, and I couldn't reach any reasonable place to find this. I'm probably the only Erlang programmer in the world trying this kind of weird stuff. So it's homework. You can do your research and figure out what's going on here. And if you find more strange situations with list incomprehensions, please let me know. I already had 2 blog posts about it. I will be extremely happy to write a 3rd one. And by the way, those people they are fighting belong to an organization called the World Taekwondo Federation. They choose the best acronym in the world for their organization. I actually have a couple of friends there, and they told me that either they already changed the name or they are planning to change it, because even if you try to Google it, you fail completely. So anyway, moving on. Back to our problem. We still have one if that we don't want the else clause there. And remember that the issue here is that on runtime, if you don't have the else clause, if you don't have a true clause, it will trigger an exception, an error telling you that you don't have a true clause. So since that is in runtime, that thing is an exception, you can catch an exception. There is an elegant way of catching exceptions in Erlang with try, catch, whatnot. I will tell you a couple of things about it later. But there is also an inelegant way of catching exceptions, which is this one. We turn that thing into this. That catch there is basically swallowing every possible error in the expression on the right. And so if the if expression fails, the error will disappear. It will be returned as the value of the expression in general, but we are not assigning it to any variable, so it's fine. And if you cannot see what's the issue with this, what's wrong with this implementation, remember that catch swallows every error in the whole expression, not just in the guard, in the if clause. It's everything. If your code inside the if fails, it will also swallow the exception. But since our code It's just something printing out something in the console. We don't care. And then we can compile our program, run it, and there you go. Perfect. And now, since we compressed all the else clauses, we remove all the else clauses, we can go back to just one column. Genius. Amazing. I personally requesting like saying sorry to your future colleagues and even your future self if you ever try to maintain this code. But the code is small. I give you that. So this is Erlang, and this is a module that runs the FizzBuzz algorithm as requested. But if you ever see Erlang mentioned everywhere, you will also see some other words around it. So where is OTP here? Everybody tells me that Erlang is Erlang OTP. You have to use OTP, you have to use GenServer, you have to use the framework. So let's use the framework. We go to the Erlang documentation, we Google for it, we find a very nice GenServer implementation there. So we copy the implementation and we end up with this. To the right of it, we have the recursive function that we know, and we are not going to change anywhere because we don't want to maintain that code anymore. This is a function worth of a comment saying don't touch this. So we will remove it so we don't see it anymore. Done. Back to one column with the hidden part on the right. And so we're implementing a GenServer. Let's start with the worst possible implementation of a GenServer ever, but it's copied from the documentation, so it has to work. It's basically this. We start the GenServer called module, like the same module that we are. That's a macro with the question mark there is a macro. And as a parameter, we provide the number and no options there. That's the third part, no options. And so if it returns, if it creates a process, then we return OK. And if it doesn't create a process, we print, because it returns an error, we print the IO format there with not the number as we did before. So when the process is started by GenServer start link, what will happen is that the new process will evaluate the init function with the provided parameter. This one. This function basically, as it's expressed in the Erlang documentation clearly, it can return either OK and the state of the GenServer or stop and an error. And so the GenServer is not even initialized. The process is terminated immediately. So we are abusing GenServer a bit because we are starting servers and not stopping them. So every time we run this function, we will have a new server that sits idle in the background. But for starters, this should be a really simple and working implementation of this. So let's compile the mode as usual. What just happened? And if you see, I copied everything from the web, from the documentation, the Erlang documentation. You can go check it. But I didn't copy one very, very important thing. Remember when we started this whole presentation, I created a module with just one line. Well, that line compiled in every single iteration until this point, but not now, because even if the parentheses are optional, if you don't put the parentheses, the module macro is not defined. And if the module macro is not defined, you cannot use it, of course. So this is required if you are going to use that macro. My advice, don't use macros, period. Not that one, not any other one. But if you're going to use it, you have to use parentheses, like this. Now it compiles. And if we want to run up to 25, perfectly fine. We have an enable GenServer. We are leaking GenServers in memory, but that doesn't matter. And so the other thing that we need to try is what happens if we provide improper input, not the number. And so we expect to see something that says that prints out the error, not the number, blah. And that's an exception exit, which is nice, but it's not exactly what we were expecting. It's a little bit different. Remember, we actually wanted a message saying not a number and then the provided input. And instead we got an exception. Okay, let's see what we can do. So we got an exception, right? How do we deal with exceptions? We added try catch. I told you there is an elegant way in Erlang to handle exceptions. This one, we add a try, we add a catch, and we print the exception, right? Okay, let's go. So we compile, we try with the number. The exception like went through our try catch and directly into the shell. We are not very happy with this. So remember I told you there is an inelegant way to catch exception. Let's use that thing. Catch should swallow the exception. Okay, let's try with another try. And now we try like this. So if there is an exception in the shell, we should see a tuple X with the exception. And nope. But our friend Chuck here has the answer. The thing here is that exit signals travel faster than exceptions. And since the process shell is restarted every time it dies, but printing the exception first, we can trap exit signals from the other process. And if we do, then we see the error message. How or why do we get those super fast exit signals first, except if we trap them? Well, this is the thing. We copied the code, and the code says start link. And start link links the process where we try to print out the FizzBuzz numbers and words with the one that we were working on, the shell. Since they are linked, when one dies, the other dies as well. But the shell is restarted. So we don't notice that we are actually in a different process, but we are. So we can change that, not link the processes, let the gen server die, and they don't emit exit signals, and we're fine. So we use start instead of start link. There you go. Compiling. We go back to the previous state so that if the server crashes and it's linked, we will see an exception. I didn't forget, you see. But we try with an error, and of course, it prints out the expected message. Cool. But this gen server, as I told you, is leaking. It's not the way of implementing gen servers. The idea here is to have a server running and ask the server for things, multiple ones, not just a single one. So let's try it with a proper server. Instead of this thing, we move to this other thing. So what I did was changing start so that the initial parameter, the number, is not provided there. You have to start the server first, and then you can call up to a number. And when you call up to a number, the server then prints out the FizzBuzz and the numbers and keeps running. So you can ask multiple times. You can ask all the times you want as long as the server is running. But there is one particular detail here. I removed the number as the parameter for init, so I put something else. I put nothing. Nothing. And let me digress a little bit about why I did that. Remember, I copied the gen server implementation from the OTP docs. And they say this. Basically, this is the tricky part. When you call gen server start link, or for what it's worth, when you call gen server start, it's the same. You can provide 4 parameters. The first one is the name for the gen server, in this case, ch3. The second one is the module implementing the gen server, in this case, ch3. That's why we generally use question mark module. The third one is the argument for the initial function. And the fourth one is the list of options on how to start the Gen server. But again, the third parameter is specified as the list of arguments for the initial function. But how many arguments does the initial function have? Just one. This is one of the things that I keep finding students, because I worked as a trainer, I keep finding students failing to grasp this concept time and time again. And the way to solve it is actually pretty simple. It's in the documentation. The problem is in the documentation, not in the implementation of things. So basically, over here, the list with X in there, students usually think of the list of arguments to init. And if it has one argument, it's a list with one element. So they implement init with an argument, single one, which is the X that they receive. And as you can imagine, this clearly fails because you cannot sum a list with an X plus 2. That fails. Because args is not a list of arguments. Args is actually an argument, a single one. Is the argument for init. Why do the Erlang docs have a list? Because they used to think that using a list was the right way to pass multiple arguments to init if you need to. Say if you need to pass 2 arguments, like this. But actually, that's not the right way to do it, because the lists are usually stuff for changing things that change size across time. You add elements, you remove elements, you filter, whatever. So my advice is not to use lists for that. Instead, use a tuple. Tuple are fixed size. So if you need 2 things, you put those 2 things into one tuple. Or even better, you can use a map with named arguments, like first and second and whatnot. And if you don't have anything to provide to the server, since you still have one argument, you have to provide something, and Erlang has atoms, you can provide nothing. That's it. And now, back to the show. We go back to handle call, the function that is evaluated when you try to run the up-to algorithm. From the outside, there is a Gen server call with the tuple, again, not a list, the tuple, with an atom up to and the number you want to count up to. So first, we want to validate that the number is a number, and if not, throw an error. And here I'm using the and also trick because I still don't want elseless ifs. So there you go. If it's not a number, and also throw error not a number. But if it's a number, it will move through and count up to whatever number. So compiling the module, starting the server, counting up to 25, and since the server is already started and didn't die, we can try with some other parameter. For instance, not a number, and so we should see the message printed out saying that it's not a number. Well, actually no, because as it says there, the function fizbus terminate is undefined. It's not defined. So if the function is not defined, we need to define it. So we go back to the code and we actually define the function. This is the function that it's evaluated when the server terminates. And since we have a reason, we can, print out the reason for the termination of the server. So we compile the code, we start the server, we count up to not the number, and the server terminated with a reason. It evaluated the terminate function, fine. But then there was this bad return value, error not number, etc., etc. And we actually wanted to return just error not number so we can print the message. But if this is one of those tricky things that happen in Erlang, that is when you think you're throwing an exception, you're not actually throwing an exception. You're doing something slightly different that I will go into in a second. But basically, this is the key here. What you are doing when throwing an exception is actually providing an early result. So if you do, instead of return error, not number, you provide something that looks like the expected result of the function, it will actually return that thing. Let's see. We compile, we start, we count up to not a number, and there you go. We get the error printed out. And even more, the server didn't terminate because it didn't crash. So we can still count up to a number. Very nice. So let me digress a little bit about this particular topic, which is handling errors in Erlang. And this is something that I've been meaning to write a blog post about, and I've been having conversations with many Erlang folks, like long-time Erlang folks, Robert Bearding, Simon Thompson, and multiple others. So this is part of the why Erlang is usually so strange for people. Part of the reason. There are many others. This is part. So in Erlang, an error is what you will think of an error. A runtime error, like dividing by 0, or if you want to raise an error in your function, you do error and it raises an error. Nothing particularly funky here. What you will think of throw in other languages, when you're going to throw an exception, the general idiom for Erlang is for the function to return something along the lines of error, reason, a tuple. So if you have expected bad results, you don't throw something. You return error, so that on the other side, if they don't want to deal with the errors, they can just pattern match with OK, and it doesn't match, so it crashes. But if they want to deal with it, they do a case, and there are tools to validate that if the function returns an error, possibly returns an error, and if you're not contemplating that situation, it will give you a warning, so fine. But this trips people because throw actually exists in Erlang, but it's not supposed to be used to throw exceptions. The reasonable way of using throw, I will tell you in a second, but there is another scenario, because Erlang has two phases. You can talk about sequential Erlang, but you can also talk about concurrent Erlang. And concurrent Erlang, you have to decide if your process should die. Not only return a problem, like inform of a problem, but you also die. So if the result is really bad, you want to crash your process, not the virtual machine, mind you, just the process evaluating the function where you're at. And that's done with exit, not throw. Again, you don't throw an exception to kill a process. You exit the process. And that propagates an exit signal and many other things. But then there is another thing. What happens when you want to return from a function before finishing the evaluation of it? That's when you use throw. Throw was created for non-local return. And the easiest way I can show you, and it's not very easy, but more or less, is say you have a function to double every number in a list. You want to traverse the list, but if something is not a number, you want to throw an error, like raise an error. In this case, return an error. So you have two ways of implementing this. You can do this, where the anonymous function validates for each element that it is a number, and if it's not, it evaluates to not number. You will end up with a list containing multiple not numbers in between for everything that is not a number. So then you check if not number is a member of the result, and if it is, then you error. But if the list is arbitrarily long and the first element is already not a number, you will waste a lot of time traversing all the elements in the list. So if you don't want to waste that and you want to just stop the looping in the middle of it, as soon as you find something that's not a number, you implement the thing like this. This will throw, will do like a return from within the anonymous function to the first catch that's right above it in the call stack. In this case, the one at the bottom, throw not number, so you can return an error properly from it. That's the way it was meant to be, but they poorly chosen the word throw for this return statement and confused the hell out of every single developer, Erlang developer, after the implementation of this thing. All right. And finally, let's go back to where we started. Remember, it has to be a script. It didn't need, it could be, you can write a module, but it actually, the expected result was a script, and Erlang provides a way for writing scripts called eScript. And for, as in any other language, there is a main function, a point of entry in the script, and it's similar to every other language. So you can, if there are no arguments, IO format, this is a way of using this tool, whatever. But if there is an argument, at least one, we start the server and make it print up to that number. We go to the shell, we don't need to compile anymore. We run it, it tells us you're missing the number. We run it with the number. And of course, it tells us that this is not a number. Right, this is a string. We are in the shell. The shell doesn't know that we are talking numbers here. Right, cool. So we have to convert the thing. So we go back to our code and just turn the list into an integer. Easy peasy. So we go back to the shell, run it with 25, prints out the expected result, everybody's happy. Now we run it with something that it's not an integer, and we expect to see not the number as we saw before. But no, we have an exception error. Of course, because list to integer provided some wacky string doesn't return an error. Wait, I told you that the way of handling these things was returning an error. Well, sometimes it is different. Sometimes, maybe not. So for this function, it actually raises an error. And so we have to try catch that error or use a function that actually returns an error as I described it before. Like this. String to integer provided an input either returns the integer or it returns an error with a description, whatever, doesn't matter. So if it's not an integer, we leave it, and so we get the algorithm to return, to print out the message that we want. Like this. Cool. What are we missing here? We're missing the last bullet in the list. It should work for floating point numbers. So for the sake of it, let's try. Let's see what happens. And of course, what do you expect? 25.0 is not an integer. It won't work. Fair enough. Instead of converting to integers, we have to convert to float. Easy peasy. We convert to float, provide the input. Fair enough. So this was 25. Works perfectly. This was not a number, returns an error. Everybody's happy until you try this was 25 and you get not a number. And right, yeah, 25 is not a float. This is not a float. This is an integer. All right, so what do? We contemplate this situation, and if it's not a float, it might be an integer. And if it's an integer, cool. So we go again to the console, try with 25, try with 25.0, try with something that's not a number, and yeah. And for a final trick, let me show you this. You see two case statements, one inside the other. I don't like that. I want just one, in particular, this one. And I can tell you, because brujo means sorcerer, that this will work. And in fact, this actually works. How did I do it? Magic, of course. And that's the end of my presentation.
Thank you very much, Brucio. Really appreciated your presentation. Really fun presentation to watch. And really also really, what do you call it, educative presentation.
Hopefully, yes.
Yes. I had one first question. How come you started to collect these like oddities?
I think my first one was, which one? Oh, the one with the server throwing an exception in the shell continuously. That was super tricky to find. And after I debugged the thing, and I did exactly what I showed you here. Like I added a catch, I added a try, I added another thing and another thing and another thing. And by the time I figured out what was going on, as usual, when you spend a lot of time debugging a problem, it's usually very dumb. It was very dumb. And so I wanted nobody else to step on the same stone, to fall with the same stone. And so I decided to publish it. But as soon as I told my colleagues there in INACA, I was working at the time, everybody came with, oh yes, I remember when I tried to convert an integer to float and end up writing my own function and whatnot. And so I saw, like, I always wanted to write a blog, but I never had any materials to it. I didn't want to start, with one article and then wait a year for the next one. So I collected like 10 or 20 of these, and I started writing them down. And at some point, it became it was just easier. So every people came to me telling me, "Hey, I found this other thing." So I had a field of material.
Yep. Thanks. Have you found some of this in production code also?
Every single one of them.
Okay.
Those are all from real life. Yes.
Okay. Amazing. I had one, and then I had one more question. How did you find the What the F foundation?
I have a Taekwondo practicing friends.
Ah, okay. Because if you Google it, you're not gonna find it, I assume.
No. Exactly. They at some point they actually speak Spanish, so they didn't understand the connotations of the acronym.
Yeah.
So they show me, hey, look, they admitted me in WTF, and I was, what? Where?
Okay. Yeah. Interesting. Then I have people in the chat asking, how did you do the last thing? How did you get a flow to work like that? The magic stuff. Okay, it's magic. You have to figure out yourself, everyone. Look at the code, start thinking.
I can tell you one thing. The trick is the oldest trick in the book for Erlang.
Oh, okay.
The original one for everything else.
Thank you very much again, Brucio, for coming to us today. Thanks for your presentation. I don't have any further questions, so thank you very much.
Thank you. It was a pleasure.
Yeah, really nice having you. Thanks.
Thanks.
Yes, and with that, I would like to thank both our presenters, Leonardo and Brucio, for coming to us today. And I also would like to thank the audience for coming to us today. Before we go, two things to say. We will have the next meetup will be on the 10th or on the 15th of November. It's the 10th meetup of the year, and it will be on the 15th of November. Then we're also planning for a meetup in December, the last of the year. Last slide before we go. If you want to present at a meetup, just reach out to me in whatever channel you like. I'm on most social media, or you reach out on YouTube, or you reach out on the Meetup app. If you want to sponsor a meetup, please just reach out to me again. If you're missing something, if you think we should contact someone, put someone on stage, ping me, and I can poach them and try to convince them to come and present for us. If you think we are missing a topic, we haven't covered something for a while, or if you really want to know more about something and we haven't covered it yet, again, please feel free to contact me or comment in the Meetup app or just contact me directly. With that said, again, thanks everyone for watching, and again, thank you very much to our presenters for taking your time and sharing. With that said, have a nice evening, everyone. Goodbye.